Good morning, everyone. Thank you for coming. It's a beautiful day outside. One thing I realized, everybody said how different Davos is this time. I think I have to disagree. It's always a very good collection of people, and you have rotten shoes by the end of the day. Whether it's snow or rain, your shoes do get wet out here, so I'd say it's still the same. But we're not here to talk about rain or shoes, but we'll talk about semiconductors, more like the future of semiconductor. And this panel is a little bit personal for me, because I'm personally an electrical engineer, so having surrounded by captains of the industry that define what the entire discipline of electrical engineering is and the derivatives is pretty awesome, and it's a pleasure for me. So with this, I would like to introduce some of our esteemed panelists, or who I like to call captains of the industry. With me, we have Blake, CEO of Rockwell Automation. Blake gets to play a very interesting role. He buys the chips, then he makes things with the chips that are used again to make chips. I guess the whole circular economy works here too. Next to us, we have Kevan from Intel. I guess, simply put, he makes the chips. Kevan is the Global Chief Operations Officer, responsible for everything that is required to make chips. Next, we have Eric. I guess a long history, given he's at Ericsson. I used to be at Motorola. There was a time we used to compete. No more. I'm not there anymore. And I think Eric plays a very important point where he's kind of like the traffic cop for all the data that gets created by the chips. So he's kind of the guy who knows everything that's happening in the industry from a data generation, which is again tied to chips. And last but not the least, my colleague Martin. He leads our automotive practice in Germany, and he will represent the automotive industry, which has kind of suffered a lot because of the chip shortages, but there are some very interesting and exciting things happening out there. So with this, I would like to say welcome to all of you. Just very quick ground rules. Actually, there are none. So if you guys have any questions, please raise your hand. My colleagues have their microphones so they can get it on tape. Just to be clear, anything that is recorded here will be kind of validated with the comms department before it's released. So open forum for a discussion about the future of semiconductors. We're not going to talk about the past. So with this, I would pose a question to our esteemed panelists. How do you see the future of semiconductors? Or where are the demands coming from? Or what are the demand drivers over the next horizon? And if I may say, maybe the next decade. Open to all of you. Maybe we start with you, Blake.
Sure. Well, we are ourselves a manufacturer, but our business is also supplying to manufacturers. And as IT comes to the plant floor, everything that you find is smart. And the data is not only being used to control the plant floor processes, but also taking the information from that data and bringing it to higher levels of the organization. And so that trend is only going to continue because that's the way that manufacturers differentiate. It's how they become more agile, more flexible by being able to make better use of the data. And that's a lot about the use of the data in the information layer, but I just want to draw your attention to the fundamental requirements for even the core manufacturing. I think everybody recognizes that semiconductor chips are required for automobiles on board, but also in the manufacturing process and for defense. But you may not recognize immediately that it's absolutely required to make and package the amount of food that the world needs. There's simply no way that you can do those things with manual processes. 5 billion doses of vaccine a year require semiconductor chips to make for the packaging and the validation throughout the process, the track and trace. And so we see those things only expanding as the need to live healthier, longer lives becomes a more achievable reality for the world's population and as the population grows. So we just see that demand continuing to rise exponentially.
Thank you, Blake.
No, just to build off of that, Clearly, Intel's perspective is, and one of our core belief statements is that, the digitization of everything we do is an unstoppable trend, and we see that. This started back in, 4 decades ago with, your handheld calculators and semiconductors has just been, become foundational to, the way of life, and it's like necessity for everything that either we use for building, making vaccines, to now, cars becoming a moving, computer, to, of course, the traditional business models like PCs and powering up the data centers around the world. And of course, all of this digitization, one core fundamental foundation in all that is semiconductors. So these are very, very exciting times because we have seen exponential growth for the need for semiconductors. And the use cases are changing, moving forward. Certainly from Intel's perspective, our traditional business model has always been around PCs. Of course, PC, an amazing business, continues to, provide a lot of, I would say, cash flows. And in fact, who would have thought that the last couple of years has had double-digit growth because of, just every time you hear, it's a dead business, you continue to see strong use. It's just, you saw the pandemic, people use of, phones, for their way of life, or tablets. Just people need PCs. In fact, today, we, instead of measuring it, per person, it's now becoming per household, because you need more than one system per. You have kids, you have spouses. Everybody is just using it, whether working from home, learning from home. However, the trend also continues in all the other use cases that certainly Intel has very, very strong critical need. There's a high performance, computing for enablement of all the AI and, very large processing of very large amount of data for the, just taking on and making much better decision support for very complicated world we have around us. So that trend is, again, unstoppable. But we also see strong need for, many of the legacy, processes, right? And we can certainly get more into details of, why, what's happening there. There's just a dynamic of the very, very high capital intensity for those, high performance, and essentially push continuing to drive the Moore's Law, which is absolutely alive and well, but the cost of capital continues to rise. So our view is that we as a maker of semiconductors have to support this unstoppable trend of semiconductors, but also do it in a way that's right. If again, one thing we learned the last couple of years is the balance of that global supply chain and the resiliency of that is more important than ever. Where the production of these semiconductors is just concentrated in one region of the world. And this is a supply chain discussion, and we all know when there's a shock to the system, you just cripple not just one region, but the entire world. So moving forward in the context of the future, I think the resiliency of that supply chain is critically important, and Intel is taking, very measurable and critical actions with sense of urgency to really drive the investment in, very targeted sections of the world. But also, I would say, it's also critical to do it right in the means of that as you're adding all this capacity, it's got to be done with the utmost focus in the, the ESG, of course, the environmental sustainability, the social element of it when it comes to diversity, and make sure that you're supporting that whole, training and the talent and the skills. And of course, do it with the focus on the governance and make sure that all of the right policies and the regulations are being, adopted. So that's our view. Exciting times. The growth continues. You have to adapt to the use cases, and of course, this growth has to come with doing it right.
Thank you. Eric?
Well, the demand. Today the demand is 5G in our industry. I'll talk a little bit about that. And 2030, it's going to be 6G. So that journey is a very important semiconductor journey. It's very much about new form factors in terms of XR. So that's, of course, a big demand generation. And I think underpinning these is higher performance than we've had. We're moving from best effort to segmentation, differentiation, much higher quality. So performance, super critical when it comes to the demand, and also energy efficiency. So the reason we are doing our own semiconductors, our own silicon, is really about energy performance, size, cost, weight, all of that. But let me just share a few data points on 5G first. So 5G compared to 4G, just the first instance, it has about 300 times more processing needs than 4G. And that really requires us to work with both hardware and software. Because of the massive MIMO antennas, the reason you can get gigabit per second speed in 5G is because we direct the radio energy towards the device, and that takes a lot of signal processing. So those 300 times is a big, big change. We've had about 100 times higher data rates every 10 years, over 30 years. So 100 times every 10 years. That's the mobile industry's sort of correspondence to Moore's law. 100 times every 10 years. And that's going to continue over the coming 10 years. So another 100 times higher performance over the coming 10 years. We don't see any reason why that would taper off. So that's a huge part of the demand. And still we need to meet net zero by 2040. That's our commitment. So that means that energy per bit, but also smart energy solutions for infrastructure needs to come in place. Renewable is just one part of it. Breaking the energy curve is another one. But all of this really, if you combine that with this distributed compute, you're running some of the applications on the device, glasses or some kind of carry-on or carried device, but you move much of that workload into the network infrastructure to gain efficiency and also gain performance. And then some of it, of course, will continue to be in the public cloud side. If you look at all of that, that will also fuel demand when it comes to local edge compute, running those XR applications. So I think we really see a step change going from 4G into 5G in terms of how much processing we need to provide. And then going from 5G to 6G, when we're talking about an even higher capability, we're talking about even more sensing, communication coming together, these will be another step change here. So it's not any longer the 30 years journey. Now we have really a massive increase in that speed.
Thank you, Eric. Martin?
Thank you, yes. I also believe that the positive trend will continue. And when I was listening to you, I was thinking about Moore's law. I studied computer science decades ago, and everybody has learned Moore's law, and it does not matter whether it's already still in place or not. But from the beginning, it was clear to me that semiconductors and high technology is from super importance for us in the future. And when I look today at the overall market, I can see, of course, the data need, the cloud needs. We have much more data available, which must be processed. We have AI, analytics, and a lot of stuff in all industries. And when I look as a consultant at the different lines of industries, and just in all industries is change. If you look at the automotive industries, we have more electrified cars, we have autonomous driving. If we look to the energy industry, we go more to renewable energy, so we have wind, we have solar. If you look at the communication, and you already described this with iPhones and iPads, so there's a real demand on the one side on the data, on the other side really on the products and on the services. I think what's really important is, and we see it when we separate a little bit for leading edge technology with very low nodes or the more mature, then for me personally it's also important the ecosystem. It's not just the solution or the demand, it's really the production and how do we come it, because we need machines for it, we need intelligence and development centers for this. But when I look overall at the semiconductor industry, it's very promising but also challenging.
Thank you, everyone. I do have some very quick follow-ups for all of you. And Blake, I have to give it to you. Chips for food could be the theme of the World Economic Forum maybe next time. But maybe you could elaborate a bit on that. And Kevan, you talked about strong need for legacy. I mean, we know the problems are sitting there, not so much on the leading edge, but would be good to understand from you. And as somebody said, yes, we know the investments are being made. There is a time before they'll start paying off. What do we do in the meantime? So maybe you could share a little perspective on that. Eric, you talked about the 100x data rates. What does it do to the semiconductors? Because as I believe some of the Intel folks would say, chips create the data, move the data, stores the data. So how many more chips do we need exponentially? Martin, would be good to hear from you a little bit about auto. I mean, we talk about hundreds of semiconductors going in there. What's the future out there? So maybe we start with you and come this way.
Okay, then I start with the auto. I think the automotive industry is currently really in a challenging point because we are going out from the combustion engine to the electrified cars, and we all know we need much more semiconductors in electrified cars. And it's not only about semiconductor itself, it's also about software, because we see that many manufacturers are building their own operating systems. And I see it a little bit with risk, because I would like to prefer that everybody works a little bit more together and having the same operating system. And if we do this, we need much more semiconductors in this area. And the main challenge is really bringing all together, because on the other side you have to work on the software, on the other side you need the hardware, the processors especially, and this must work together. And I think that's a very challenging time.
Thank you. Eric, what do you think impact of your 100x data speed is going to have?
Yeah, so 100x every 10 years, and 1 million times in these last 30 years, another 100 times in the coming 10 years. The data rate, the data volumes, the capacity of the networks, it's not growing as fast. We're talking about 50% plus per year. So of course that is what we have to keep up with when it comes to baseband processing. That's when it comes to the big data centers, the compute hotels more centrally. But the reason I want to point out these 100 times and the beamforming and the front end and everything that happens far out is that that kind of processing is massively more complex because of advanced MIMO, beamforming, energy consumption needs to be managed. So that's where you have a much, much bigger growth. So the 300 times that I mentioned for the first generation of 5G compared to 4G, that will continue at the same speed. And you can talk about number of chips or CPU cores, but in essence, to keep that energy consumption constant or even go down, breaking the energy curve, that is the trick. So we are having this explosion of data rates, and still we cannot afford to increase the total energy consumption, which I think is a very strong commitment when it comes to efficiency, but also architectures and all kinds of advanced AI software to create sleep modes when systems are not used. So there's a lot of things that comes with that. But that is why we can partly compensate for sort of power explosion. So I would separate between the kind of the more CPU-like baseband loads and the things that are more access near and the things that really will continue to require super advanced, dedicated ASICs.
Thank you. Kevan, the more complicated question around legacy. What do we do about them, those pesky little small chips?
Well, let's start maybe by just give you a little bit of a perspective as to why. Why is it that there's such a critical need for legacy products? You all know that semiconductor manufacturing is, especially for advanced nodes in logic, is pretty high capital intensive, right? Why is that? Because you got to keep pace with the Moore's law. You got to still, shrink, and you got to get the lithography to smaller dimensions. Well, of course, those equipments are not cheap, and in fact, they are getting more and more complex, right? The leading edge logic equipment is basically running on EUVs, right? That one company in the world, ASML, makes that. And how much are these equipment? $200, $300, $400 million, right? So the cost of capital for building leading edge is going up, right? In fact, if you look at how much it costs a wafer, about 50% of your cost on a leading edge is just lithography, right? So as you look at it and as you become pragmatic and become practical, right? So you got to be very, very, mindful of how you're using that very critical, real estate for what you're integrating in there. So if you're looking at the traditional model of monolithic integration of all your, key elements of what the chip needs, right? It's, of course, you can do it that way, but versus the economics of, hey, you say, you know what? All these use cases, whether it's in automotive, whether it's in communication, whether it's in IT or all the other, the use cases are different. What you integrate in there in terms of your memory needs and your PCH needs or your, all the graphics, do you really need, how do you optimize around what is critical need? And this is where this very new trend is coming, which we call the disaggregated manufacturing or Intel's investment in advanced packaging, where you're bringing different chiplets, right? And these chiplets, whether it's an RF device or whether it could be a memory or it could be a graphics, they don't need to be on the leading edge node, right? So think about you bring a legacy wafer, you bring a leading edge wafer, you marry them together, you put a basically wafer level assembly of that. It's like a fab, but not quite fab. It's like assembly and test, but not quite assembly and test. So it's somewhere in between, right? Where you're doing this, what we call the advanced packaging, right? And this is where the trend is where we see is going. Lots of amazing, already enough, innovations there, but that has its own sort of, Moore's law of really driving, its packaging densities, all the key innovations needed in there in order to, at the end of the day, make it economicals for the end users, right? Of what is the use case? There's so much, BOM a car can afford. There's so much BOM in a wireless, 5G system that the customer can afford. So you customize the solution. And with that comes, of course, the critical need for, offering foundry services to customers who customize their design and really utilizing this, new trend in production of semiconductors to really tailor and these chiplets that come together at the end to one package, they don't need to be on leading edge. And that's why you see the need for legacy. In fact, even to our surprise, it continues, even some of those demand is actually going up. Those could be for power modules, PMICs, it could be for, like I said, RF, it could be graphics. You can be totally fine in having a RF chipset, or you can be totally fine having a graphics chipset on a 10 nanometer or 14 nanometer node. So it comes down to economics, right? So Moore's law will continue. Transistor density will continue for leading edge because you need those for high performance computing. But then you need to couple that with other, chiplets or chipsets for supporting the use case. And that's where I think the need for that, legacy fabs will be at least for the foreseeable future, is going to be critical.
Okay, one quick follow-up, and I'm sure people may be wondering. We read in the press about you folks, the Taiwanese folks, the Korean folks investing in leading edge. not a whole lot is talked about the legacy investments. What, in your opinion, is happening, and are you satisfied with that? And if not, what would you expect somebody who's playing in the legacy space? Or is that something that IFS would get into to close this gap? Because as you explained, that gap, that demand is there for the this was one of the best explanations for demand and legacy that I personally heard. So thank you.
Well, yeah, if again, you go back into the why, if you have the old business model, which is you're always moving to the leading edge and you're always doing monolithic integration, that means that you just keep moving to the new node, right? Because you just transition. That's been Intel's traditional model. You know, you take the legacy, you yank it out, you put the new stuff in. But you notice also foundry players, they don't do that, right? So it's not, of course you see there's need for 28 nanometer, you see need for some of these legacy, and capacity is being added. You know, you see there is as big of a demand for legacy as it is for leading edge. There's no question about that. That's why the equipment suppliers are crushed right now. They're constrained because they're making equipment that are 15 years old. Having said that, to your question about Intel's strategy is we are not going to displace the legacy nodes. We are going to keep running them. For example, we are running 14 nanometer in Ireland or in Arizona. We're just going to keep running them. They're not going to be on leading edge. Of course, we transition new fabs. You hear all these new investments, right? They're all going to be on leading edge while you continue running your legacy. And there's good economics because these are fully depreciated assets. They will do what I just said, which is, produce the PCH or the chiplets that you need in order to really couple it with your leading edge. And it's whether for Intel or whether it's for other customers who need their customized solutions. So yeah, so that's a business model certainly Intel is moving to, and something we're already acting upon. And I believe that the rest of the industry is already following that, and that's going to continue. So two ways to address the legacy capacity. One is just go build new capacity, and the second part is just those who are making leading edge, they just keep running it.
Mm-hmm. Thank you.
Yeah.
Blake, this is all exciting stuff.
Yeah.
You scare me. When you said food, that comes really, really close to home. Maybe we can delay our PC by a month. So tell me more, what is that keeps you awake? Because you pretty much support all the manufacturing industries around. What is that scares you most? That what if the chips that you need are not there? Which industries get hit the most and which will have, and I'm not trying to create a scaremonger here, but let's be practical about that.
Well, one of the things that keeps me awake at night is the subject that Keyvan just talked about, and that's the continuing commitment to legacy nodes. So when we talked about chips for food, think about in a bakery and the need to regulate the temperature as the bread's being baked and conveyed through the oven and then to the packaging at the end to make sure that it doesn't spoil on the way to the grocery store or wherever it's going. And overwhelmingly, the equipment that is controlling the speed and the temperature and the humidity and all those things are on legacy nodes. So we start at 28 nanometers and get larger. And we're an important part of the business model, I think, for our suppliers because we're a good source of profit and we don't change very often. The equipment that goes into that bakery is expected to last for 20 or 30 years. They don't want to change. They don't care about new enhancements unless it's going to fundamentally change what they're doing. So they want to put that variable speed drive or that programmable controller and just let it go until it can't go anymore. And because of the environmental requirements and the need for stability, then those legacy nodes are overwhelmingly what are used in the industrial and certainly in the automation industry. Going forward, we'll see a gradual move to newer node technologies as we start moving more to software-defined architectures, and as AI becomes a fundamental part of what we're doing, because sometimes the workforce is not able to troubleshoot and keep the machinery running as much as you would like, and so fault-tolerant control, being able to run autonomously, is a big discussion topic in the automation industry today. So there'll be pressure to move to newer node technologies, but it'll be very slow. And the other piece of it is that for automation suppliers, we think we ship a lot of product. We're an order of magnitude or two less than the people who are most interested in the leading node technologies, and we would not win, to get our demands met if we tried to play in the 5 nanometer technology. So we're happy where we are. We're hoping more people have an ability to move to the more leading edge nodes, to give us more room where we're comfortable, which is more in the legacy space.
Yep.
So you are rooting for new nodes so you can get the legacy ones. I like that.
It's a piece of it. It is.
Wonderful. Folks, very quick check. Anybody has any pressing question before we move to the next topic? Wonderful. So some of you actually started talking about technology. I want to pose it for all of you. What are some of the technological evolutions you see over the next decade, which are not incremental, which you think are going to really disrupt? And I do like what Eric says about 100 times data rates. That's very interesting what we could do with that. If you ask my kid, he's going to say, I can play real-time video games, and I think a lot of us have different reasons to use higher data rates. So from your perspective of your industry, and Kevan, sorry to start with you because you're kind of at the center of the universe. What do you see with these chips happening over, say, 7, 8, 9 years from now by the time we get to 2030? And then I would pose the same question to the rest of you. What are the big disruptions you are expecting in your industry?
Yeah, I think at the core of it, Moore's Law is going to continue. And that's the center of innovation for just continued transistor density. And a company like Intel, we will not stop until every element of that periodic table is exhausted, because it's just a human just drive, and it's not just for Intel, but the entire industry and the equipment, material suppliers, etc. So that's the one, core, part of this semiconductors that's going to continue. But when as I started commenting earlier, is all this capacity, all this unstoppable trend for our semiconductor growth has to be done, and it has to be done right. And that's where focus on environment and sustainability for all of us, from a end customer use when they say net zero, versus a maker of the chips. That's where when you really go deep into what does it really mean, it requires fundamental changes in the way you basically go about, producing, fundamental R&D that's needed in order to really get down to those levels. We have to look at different chemistries, different materials. Equipment industry has to adapt to, new, methods of production that, your abatement systems, all these things have to, it's not a simple task. It's going to be a next 20, 30 years of just relentless focus of what it takes. And, hopefully sooner than later, the industry is going to have a unified metric that, certainly in semiconductors that we all rally behind, and, you measure it so that you can improve it. That to me is the critical need for the world, that the whole semiconductor industry needs to rise to the challenge, and it starts with the fundamental research, R&D, all the way into bring it into high volume manufacturing. It takes investment, it takes innovation, it takes the new set of skills in order to really drive this solution with innovation. Otherwise, it's going to be just a talk and all kinds of metrics that nobody can understand.
Kevan, do you see any radically different technology coming in how semiconductors will be manufactured? Or do we still see the same process of the 200, 300, 400 million EUVs continuing?
No, I think if you think about the capital intensity of what it takes for the leading edge, certainly you need both the leading and legacy, but the leading edge, there's only 3 players in the world that are, it's the industry, because of its capital intensity, has started to, consolidate, and there's Intel, US company, TSMC, Taiwan, which they're foundry, and of course Samsung, Korean. So these are the 3 companies. And one fab module is how much? $10, $15 billion. And that cost keeps going up because process flow goes longer. These EUV equipments, they will be more advanced in their NA capabilities, not numerical aperture capabilities. So the industry is going to evolve, right? Right now, there's no better solution to do those patterning. But just like everything else, right? The fundamentals of what the end state is, which is you got to drive the Moore's law, that's not going to change. But how you get there, I have no doubt that innovation will continue because there is, of course, the design, there is the end use case of it. Like I gave an example of advanced packaging, right? Is where innovation will continue to mitigate a lot of the economical pressures. But even in the semiconductor industry, equipment makers are going to need to get creative. They got to drive productivity, use of automation. All these things are going to be new innovations that just keeps coming, right? But the end state, which is driving the Moore's law, that's not going to change. So I wouldn't say there's any new rabbit out of the hat that nobody knows about. We as a company, we look at all different materials. Look at the periodic table. Those are all of our core, hardcore research that's being done. Equipment makers working clearly closely with us on new capabilities for whether it's deposition or lithography or these kind of things. And maybe 1 out of 10 will work. But that's an unstoppable trend that this industry will continue. So that would be my view of it, and the need for semiconductors as it is continuing to grow, that innovation and that investment will continue.
Thank you. Eric, what do you think? What gets you excited about the technology evolution in your industry? Now, you told us 100x. Now, I think that was 45 minutes ago, so it's boring. You've got to come up with something more interesting.
Yeah. I think it comes down to the fact that we've thought of networks and the IT data center as something disjunct or something that you connect perhaps with a wire or wireless at some point in time. But we are moving quite fast towards something which is more of a heterogeneous platform. And that platform requires unique compute, unique capabilities, not just in the smartphone or the tablet and on the data center side. It's really more of a continuum in terms of processing, of course storage, but memory, but it's very much about having energy efficiency at the top of that optimization. And when you go sort of wholeheartedly into saving energy or just using as much energy that you absolutely have to do, it changes everything. You get into advanced single bit inference where that makes sense. You have the super high performance at another part of the network. And this needs to connect. This needs to really be orchestrated across. You need to be able to place and replace workloads wherever it makes sense. And I think that will be a fantastic journey, both on the hardware side, which is why I keep coming back to the energy performance. There is no way to do this only in software. This has to be done with the latest hardware, but also when you combine that with really advanced AI and of course automation capabilities on the software layer, it is really something that can help. I think maybe not the bakery overnight. I see your point about long cycles, But I'm more excited about the fact that we'll have a continuous evolution, both on the hardware and the software side. And whether it's good or bad, I mean, for you to tell, but I do see it as an unstoppable trend as well, that the more we can put into a commonly shared infrastructure platform, in our case very much 5G with edge cloud, the more we can bring down cost, we can get energy consumption under control, but we can also start to offer services which are much more differentiated than we've had today. I think this is just painful to see how poor things work, whether it's the devices or the networks. We have to up the game an order of magnitude when it comes to reliability, resiliency, security, all of these things really being core in that platform. And with the platform thinking, I think we're much more ready now to bring on requirements that are as diverse as you mentioned, Keivan, that this is not one size fits all, it's much more of a heterogeneous platform.
Thank you, Eric. Martin,
Maybe
EVs and autonomous driving, what's next?
maybe I risk a little bit with a hypothesis, but I think having also a little bit the European perspective. I think first of all, I think technology was always a driver when we look at the semiconductors, getting smaller, getting more energy efficient and all this stuff. When I look to the European semiconductor industry and I look at NXP, STM, Infineon, I see very successful high technology companies who have been able over the past to build semiconductors because they have been working in some kind of ecosystem with machinery companies, R&D centers, also the demand side with the automotive industry and all this stuff. And I think the next step is of course being better in technology, but I think it's also important, that's my hypothesis, for the leading edge technologies that we also build maybe more on a local side, the ecosystems, meaning the machines, meaning the R&D centers which we have, and being close to the customers. The power can be much higher if people working much more together and finding together solutions. We also see already, and also since many years, that some companies like Apple or Amazon are designing their own chips and let them produce by TSMC. And I think if leading edge technology comes more and more together with the demand side on the automotive side, of course, communication, this could be the next step from my perspective.
Mm-hmm. Blake, how do you see this?
Well, I think we're going to continue to, as I said, evolve our products to be more software defined. Mm-hmm. There'll be a mix, I think, of ASICs as well as off the shelf. There's a very long tail in industry because of the unbelievable variety of inputs and outputs and signal processing across the industry. And so as we deal with current issues, it's a very long list, and it's unlikely to converge to just 2 or 3 platforms, I think, certainly not in the next 10 years. And part of that is, again, because of this very large installed base and the need to be backward compatible and forward compatible. Manufacturing in plants are increasingly complex systems. Nothing is an island by itself, and so the communications, the way that you handle data, the scalability of artificial intelligence, from the device looking at junction temperature on a power transistor all the way up to applications of AI looking at massive amounts of data going across multiple facilities. Scalability is what's interested. And I'll finish with that. Cloud is going to play a larger and larger role in the plant. The further away you get from closed loop deterministic control, the more cloud has a role. So when you're talking about microseconds and a safety circuit, that's unlikely to have a loop that's closed in the cloud any more than you want your airbag deployed in your car through the cloud. But as you start looking at benchmarking overall equipment efficiency from one line to the next across a worldwide fleet, that's a classic example where the cloud makes good sense.
That's beautiful. I would not have connected those dots. Thank you. Well,
But if I may just provide a perspective, I mean, first of all, it's when you say, hey, what are the disruptive technologies? I mean, all of us sort of gave you an answer, but every element of the use case, whether it's, talking about the customer, where the power efficiency, and that's one element. You talk about the manufacturing process, that's one element. But also, more important than ever, is the complexity of this entire supply chain of all coming together is something that we got to think differently, moving forward. How do you prepare this huge infrastructure to be able to continue to provide the end users with what they're looking for, with predictability, with agility, and it starts with the, of course, the assets you need, but also let's not forget the human, the technology it takes to actually get since 1800s, we have been thinking about, hey, the only way to learn is like you go sit in a classroom and you learn, right? A teacher teaches you. Well, with such a massive need for bringing talent into these fields, right? We also have to adapt with new technologies, even in every element of what it takes in order to make sure this whole semiconductor industry continues to thrive. Are there, at least in the pandemic, we learned that you can learn from home. There are technologies that can become available, even at the spur of the moment, the Zooms and things like that. So, clearly, certainly it's my personal view that in every aspect of this entire ecosystem of what it takes to make it successful, there needs to be innovation. The innovation cannot stop. And it's an unstoppable trend that's just going to continue.
Thank you. Could you please bring the mic, please? Sorry.
Thank you. So Andrea Fuder, Chief Purchasing Officer, Volvo Group. I think, Keivan, I have questions to you mainly, and it's two-sided. One is, in all this growth you described, do you see a limit because of having a limited choice in the equipment supply base? It's one question. And then a complete different, we talk now a lot about CO2 neutral
Yes.
value chain, etc. Can you reflect also a little bit on water usage?
Yeah.
And also on raw material availability. Of course, you can say silicon is sand, yeah, but you cannot use every sand. And already today, sand is a critical raw material because it destroys the living environment of people. So can you reflect a little bit on this too?
Yeah, well, those are very big questions
I
within
know.
one question. So I think you had three parts. I'll take an attempt. I'll keep it short. I think your first question was just the equipment industries and the choices. Typically in all the key elements of the process that you use for semiconductors, you have etching, you have polishing, you have deposition. You always have, multiple players, multiple big players in each of those. The place that really right now sort of the only game in town in the leading edge, right, enablement is really lithography, as I mentioned. And that's ASML, which has sort of been I would say the leading provider of these. Nobody else can make the kind of, the most probably amazing technologically advanced piece of equipment that you can ever imagine. I was personally in Van Hoven looking at the equipment itself. It was like, oh my God, it is just, this is even the next generation. So I would say that's the area where the choices are becoming, limited. However, all the other areas, there is the number 2 or number 3 that I think it's very healthy for the equipment industry. Your second question was around, the water usage. Yeah, that's right, raw material. So let me respond to the water. Yes, semiconductor manufacturing takes a lot of water. In our CSR report, I think we reported something like a little over 40 billion gallons of water that Intel used. However, there is technologies, there are ways that you can actually do it responsibly. And it's not a new concept to Intel. Intel has been investing for decades to make sure that when it comes into water usage, electrical usage, that we are very responsible. So for every major manufacturing factory, a semiconductor factory, certainly Intel strategies, we build a water recycling plant right next to it. These are several $100 million where you're actually able to, return back the water that you use. Either reuse it or return it back to the municipality or basically put a use of it. And for us, it's a little over 95% of today is where we actually reuse our water. And in fact, with the goal to be net positive. Well, how do you get net positive? And that is by your projects with the community, with the reservoirs, with the technological innovations, right? You actually, conserve more water. Critically important for the industry, right? That everybody's got to move to this model, and certainly we also have ways to go, but that's the example of the water usage for the industry. The second part around, the carbon emissions, and that goes back to the, it starts with the grassroots R&D. It's abatement systems. It's the driving not just the power usage that you have in your process, but also the end products, right? The energy efficiency at the end products is about sustainability. So this is an element that I think the entire industry is very new for. We don't even have standardized metric that we can measure. One company says, I'll be net zero. Another one says, yes, I am there. And someone says, how do you do apples to apples comparison? So these are things that the industry have to come together, be very objective in setting some measurable goals. If you can measure it, you can improve it, right? So I think that's an area that is going to continue. Now, of course, our operation is a little over 80% of our sources of electricity is from renewable sources. In US, Malaysia, Israel, Europe, they're 100% from sources of renewable, but we still have ways to go, and certainly by 2030, we plan to be 100% in all of our locations. But again, it's a call to action for the entire industry to come along. This is in the context of sustainability or just the availability of the raw materials?
Availability and also how it is availability, but also how it is harvested in a sustainable way for the environment, and for the people living environment.
No, good. Yeah, that's an excellent question. In fact, last week we had a supplier summit of all of our, certainly Intel suppliers, 600 plus suppliers, who big part of the call to action is all the suppliers, right? They have their own set of goals, both for investment, the use cases of those minerals, how those minerals are being mined and manufactured with focus on people and human rights, with audits that certainly Intel very seriously does multiple times per year to make sure that they are done right. But in terms of the supply, and I think part of your question was about just, in the semiconductor, certainly for Intel products, the use of rare earth contents, minerals, is not as huge as given just the device and the transistor usages. We use tungsten, cobalt, copper. Unlike a car industry where lithium is needed for batteries in a much larger use cases. But even that, it's got its own. You think long term, 10, 20, 30 years. The balance of that supply chain is also becoming critical. You look really deep into the, we obviously don't buy directly from mines, but you look at the supply chain where these things are sourced. we see major concentration in certain, areas of the world of certain elements that the entire world chip industry, relies upon. So back to the whole, learning from the last 2 years, the resiliency of that supply chain is not just where you're actually getting the chip. It's also go look into the sub-levels of your supply, all the way to where it's actually being refined and mined, is more critical than ever before, which is not something we used to think about.
Mm-hmm. Thank you, Kevin. Any other questions, please?
I'm Shiro Kanbei from Sony. So,
Sorry, from where?
Sony
Sony,
Group.
okay, great.
Yes. And my question is a bit different, relating to the relationship between the semiconductor industry and government or public sectors. And because of the current shortage of the semiconductors, as well as the national security issues, every government are very much keen to really compete, to really solicit investment into their own state or country for semiconductor manufacturing. So Sony is one of the big users of semiconductors. We are very much relying on Intel. But at the same time, we are supplier of certain semiconductor like image sensors. So one of my responsibility at Sony is government relations. Yeah. For the last maybe 1 year or more, I spent a huge amount of the time to talk with the Japanese government for example, something relating to TSMCs and so on. So my concern is, of course, government is now very keen to financially support semiconductor industries. So US government, Japanese government, German government, EU are really competing each other how best to solicit investment or manufacturing in their own country. But at the same time, I'm a bit scared whether this industry can be really as a really private sector industry in a mid to long term. And it's something like a energy sector. It's partly state-owned kind of the business. So how Intel or Kearney feels about really future of semiconductor industry itself, whether this could be sustained as a really private company's business. Sorry, it's a bit difficult question.
I certainly have comments, but...
Are we going to be getting a monthly bill for semiconductor usage?
I can certainly start, and please chime in. I would say the role of both the public and the private sector is more critical than ever. And just some of the question asked about, the infrastructure needed for building a leading-edge semiconductor or operating a semiconductor fabrication facility. It's not just the private sector's role. There is responsibility, the power, the water, doing it responsibly. A company like Intel, we are not in the business of generating power with the wind or solar. These are things that, favorable regulatory policies are absolutely critical. And you look at what has happened the last 30 years, right? The lion's share of the semiconductor manufacturing have moved to Asia, and particularly Taiwan, Korea, China. And it's not because of what I would say, the US, the policies, it was a do nothing, right? So that trend is not because of do nothing planned by US. It's because of the favorable policies that these countries, put onto this, industry with a long-term vision, right? And you look at from, the structural cost, the capital intensity of what's needed in order to really get these things off the ground, the utility infrastructure needed to get these out, talent that's needed, right? You look at, China, the number of their engineering graduate, 5x of what it is in US. So these things requires clearly a, public and private, partnership. we are very encouraged that certainly in US and of course, in Europe, there is a lot of attention and with the CHIPS Act that are really put in place to help, address some of those structural costs and policy, challenges that's been facing this side of the world. But it's not fast enough. And it's something that, especially in this industry, because it's fast moving and the Moore's Law is not waiting for you, it is something that's a call to action that it's just got to be taken much, much more seriously. And even the kind of funding support that's needed, it's going to require CHIPS Act 2, CHIPS Act 3, CHIPS Act 4. It's a good start, but it needs to continue. And certainly for Japan, we are very encouraged to hear that it is also putting in a lot of favorable, thoughts and policies all the way up to the Prime Minister to really not just promote, but also preserve the industry there, which the semiconductor industry really depends on.
Thank you, Kevan. I want to be respectful for our panelists' time. If some of them can hang around, it's a small group, you can. But I do want to wrap up. But if some of you guys can stay for 5 minutes, that'll be nice. Any quick parting thoughts? And I know there are some more questions we can take later, but any quick parting thoughts from you guys?
Well, I think my final conclusion is what you have said regarding the relevance between public and industry. I think there's really a big responsibility in the politics to drive this, and this we should not underestimate also.
Yeah, I think it's about public and private, but also private to private. I think there is more need for collaboration here across geographies to be able to resolve this. And I think a very pertinent question by the Sony person, these are very important questions because it will require, I think, certainly regional collaboration much more than we've done today. Very complex supply chain, understand, but still we need to get it to work much better.
He's talking to me like a customer, It's like,
you have to.
Yeah, I just say briefly again, exciting times, tremendous growth. I think this is the world is counting on our industry in semiconductors and the technologies we provide to really make and enrich the lives of people all around the world. So good, we all have a responsibility, and certainly each of you within your segment. So it was great discussion today.
Yeah, it's as important to a country's economic security as energy, quite simply.
Yeah,
I would completely agree with you, and that's where the public and private has to work together. It's not just a business, it's more of your economic and even, I would say, national security issue. With this, I would like to give all our panelists a big round of applause. Thank you for your time, folks.
Okay.
Thank you.
Good seeing you.
Thank you.
All right.
Thank you.